So in this YouTube video, we'll be discussing the topic of, as you can see here, curved arrows. And so to start off, curved arrows are solely a pictorial representation to show the transfer of electrons in an organic reaction. And like I said, it's solely pictorial. This just helps the chemists and the students see how these electrons transfer throughout a reaction. There are two types of arrows. There are one-tailed and two-tailed. And these tails depend on the amount of electrons being transferred in the reaction. The typically less common tail is a one-tailed, and this, like I said earlier, depicts the transfer of one electron. And in this 251 class, this is something we typically don't use. What we typically use are the two-tailed arrows, and this is because it is transfer of two electrons, and we usually see a transfer of an electron pair. And so one of the challenges that I experienced early on trying to do these curved arrows is what you can see right here. I didn't know how to put the arrow as to where the tail goes, where the head goes, other things like that. So a technique that I learned early on that I thought really helped me was I would kind of pretend that I was the electron. I would I would picture, okay, where did this electron go? And I would do this for the whole reactant as well. I would ask these questions: how did this product change? Where did it get this extra electron, or where did this electron go? And asking these questions really helped me figure out, okay, this tail needs to go on this side. So yeah, what I've learned is the attacker is kind of the starting point of the actual arrow. So it is kind of the starting point of the arrow where the electrons start, and the tail is where they end up. So I guess you can call that the acceptor. So in this example I have here, I have NH3 reacts with H plus to form NH4 plus. And I told you earlier that this is wrong. And the reason that this is wrong is because what we see here is the electrons on this hydrogen attack this nitrogen. And from learning, it's impossible for this because this hydrogen does not have a pair of electrons to transfer over. So to picture this, I see, okay, I ask, okay, how did this product change? And it has this H. Where did the electrons go? The electron pair on the nitrogen were removed and formed this bond here. So how I said this was wrong, and the reason this is wrong is just it should be flipped. So this electron pair attacks this hydrogen. I'm going to write right here. We can see that this pair attacks this hydrogen and forms a new bond here. And that's kind of the best thing that I found with myself on doing curved arrows. So other things that I found challenging in this course were synthesis, kind of just synthesis problems overall. And another thing is kind of like a sub-synthesis, oxymercuration. So hopefully you learned how to do curved arrows in this video. Thanks for watching.